Hi everyone and welcome back. In our last lesson, we worked with independent events and probabilities involving the word and. Today, we are going to look at a different situation. Instead of asking whether two events occur together, we are going to ask whether one event or another event occurs. This leads us to two important ideas: mutually exclusive events and the probability of or. These concepts are closely connected, and by the end of this lesson, you know how to identify mutually exclusive events and calculate probabilities involving or. Let's get started. Let's start with a simple question. If you roll a standard six-sided die, can you roll a 2 and a 5 on the same row? The answer is no. A single roll can only land on one number. Because both events cannot happen at the same time, they are called mutually exclusive events. Two events are mutually exclusive if they cannot occur at the same time. That's the key idea to remember. If one event happens, the other cannot happen. Let's look at a few examples from the worksheet. Rolling a 2 and rolling a 5 are mutually exclusive. Drawing a king and drawing a queen from a single card draw are also mutually exclusive because one card cannot be both king and queen. Now, consider drawing a heart and drawing a queen. These are not mutually exclusive because the queen of hearts exists. A single card can satisfy both conditions. Whenever you're unsure, ask yourself, can both happen at the same time? If the answer is no, then the events are mutually exclusive. If the answer is yes, then they are not. Another way to describe mutually exclusive events is disjoint events. These two terms are interchangeable. Now that we know what mutually exclusive events are, let's see how they affect probability calculations. When mutually exclusive events are connected by the word or, we add their probabilities. So the formula is the probability of A or B equals the probability of A plus the probability of B. Notice that we're adding because there's no overlap. And this formula only applies if the two events are mutually exclusive. If they are not, we have to use a different formula. Now, let's apply that idea to an example. One card is selected from a deck of cards. What is the probability of randomly selecting a queen or a 5? So, I want to have the probability of a queen or a 5. First of all, we want to know if the event of getting a queen and the event of getting a 5 are mutually exclusive. Ask yourself, can one card be both a queen and a 5? If the card is a queen, it's not a 5. And if the card is a 5, it's not a queen. So no, one single card cannot be both a queen and a 5. So these events are mutually exclusive. Since being a queen and being a 5 are mutually exclusive, we are going to use this formula. Probability of queen or 5 equals probability of queen plus probability of 5. Now, let's find each probability. There are a total of 52 cards, and there are 4 queens. So the probability of getting a queen is 4 out of 52. For the probability of getting a 5, again, there are a total of 52 cards, and there are 4 5s. So the probability of getting a 5 is 4 out of 52. 4 over 52 plus 4 over 52 is 8 over 52. The question asks for a reduced fraction, so we need to reduce this fraction. Since both 8 and 52 are divisible by 4, so we'll divide 8 by 4 and divide 52 by 4. So we have 2 over 13.